Welcome back to day 10. Today's goal of the day, given a step function, you will be able to set up a table of values and graph. All right, ladies and gentlemen, step functions are just like piecewise functions, except when you're done, they are going to look like you have created steps that you can step on to walk upstairs or walk back downstairs. All right, so let's take a look at the definition here. So a step function, or sometimes referred to as a staircase function, is a piecewise function containing all constant pieces. The constant pieces are observed across the adjacent intervals of the function as they change value from one interval to the next. A step function is discontinuous, it's not continuous. You cannot draw a step function without removing your pencil from the paper. So it's not continuous. So I go to here, I got to lift my pencil, I come here, I can trace it, I have to lift my pencil up, I come up here, then I can trace it again. So a step function is very similar. It is a special case of a piecewise function that we learned yesterday. And we're going to set it up very similar to a piecewise function. So if we take a look here, we have 1, 2, we have 3 functions and their domains. And if we take a look over here, we have 3 pieces. All right, so let's go ahead and let's take a look at our first piecewise function, or our first step function that we're going to create. So here we go. We're going to create this step function, which is just a fancy piecewise function. So if we take a look, how many pieces do we have? 1, 2, 3, and 4. If there's 4 pieces, how many tables of values are we going to need? We're also going to need 4 tables of values. So to do this, we're going to go ahead and set up those table of values. Remember, this first part here, these are all of your y equals. And over here, this is your domain. So let's go ahead and let's set up the first one. So our first function is y equals 9. All right, so now we're going to create our table of values. Okay, so this one is x is less than -3. So I'm going to start at -3. And x has to be less than -3. So that means it's going to go -4, -5, -6. Now, did this domain give me an endpoint? Nope. So that means it's going to go on forever, and it's going to end at an arrow. Okay. Now let's go back to the beginning here. Is x less than or equal to? Well, here it's just less than, so we're not allowed to be equal to. So this is going to be an open dot. All right. Let's go ahead and let's fill it in. So if I go to y equals, and I type in 9, and then I go to my table of values, what do you realize about every single one of your y values? They're all 9s. So 9, 9, 9, and 9. So now we can go ahead and graph our first piece. So -3, -3, and then all the way up to 9. And this is going to be an open dot. -4, 9, closed dot, closed dot, closed, closed. All right, and then we can go ahead and we can connect those to create our first piece. And this goes all the way, like we said, and it has an arrow. Okay, so now we can create our second piece. So our second function is y equals 5. And now I'm going to set up my table of values. Now my domain here goes from -3 to 1. So -3, -2, -1, 0, and 1. Now if I look carefully, the -3 is less than or equal to, which means this is a closed dot. We're going to shade it in. And the 1, we're not allowed to be equal to, we just have to be less than, so this is an open dot. Now if I go back to my tables, I type in, this time instead of a 9, a 5. What do you notice about all of your y values? Every single one of them is a 5. Okay, so now we can go ahead and plot those pieces. So -3 and up to 5, this gets a closed dot. -2 dot, closed dot, closed dot, closed dot, and 1, 5, this is an open dot. So make sure it's nice, big, and open, and then we connect those points. Now we have our second piece. Now for our third piece, y is equal to +1. So I go x, y, and my x's, my domain is from 1 to 5. So 1, 2, 3, 4, and 5. Now let's look for our open and closed dots. 1 is less than or equal to, so this is a closed dot. And the 5 has no equal to symbol, so that's an open dot. And now we can go to our y equals. We type in a 1, and I notice every single one of my y values now is a 1. So 1, 1, 1, 1, and 1. And now we can go ahead and plot. So 1, 1 gets a closed dot. 2, 1 is a closed dot. 3, 1 is a closed dot. 4, 1 is a closed dot. And 5, 1 is an open dot. And then I can connect those. All right, let's take a look then. Our very last one is y equals -3. And now I can make my table of values. I'm going to go from 5 to 9. And if I look carefully, we have equal to, so these are both closed dots. And this time it's y is equal to -3. I go to my y equals, and every one of my y's is -3. All right, so let's go ahead and plot those now. So 5, -1, 2, 3, closed dot. Closed dot, closed dot, closed dot. 9, -3 is another closed dot. And now I can connect those. So ladies and gentlemen, you just created your very first step function. So we're going to step down each interval. Nicely done. All right, let's go ahead. We're going to flip to the back. All right, so number 2. To the right is a graph that represents the price of mail a package at the U.S. Post Office in terms of weight of the package. Use the graph to write the equation of this function. All right, so if we take a look here, we need to write the function. So let's take a look. How many pieces do we have? 1, 2, 3, 4, 5, 6. So we have 6 pieces. So 1, 2, 3, 4, 5, 6. Okay, we need 6 pieces. Remember, first we write the function, then we have to write the domain. So we're going to interpret this graph into the function form. So let's take a look at our first function. So our first function, okay, it goes straight across your screen. Now, didn't all of these go straight across? And if you noticed, all of these here, they were just the number that they were equal to on the y-axis. So let's take a look at our y-axis. So our first function, okay, what is its value? Its value is y equals 39. Okay, and it's 39 when, remember, these are your x's, these are your y's. When your x is between what two values? When x is between 0 and 1. So x is between 0 and 1. Now look carefully. Where's the open dot? Where's the closed dot? So since it's closed at 1, the 1 gets the equal to symbol. Okay, now let's take a look at our next piece. Our next piece is up here. Let's look at its y value. Its y value is 41. And what are the x values? So what are our x values located? They're from 1 to 2. So this is when x is between 1 and 2. And which one has the closed dot? Well, that's the 2, so that one gets the equal to symbol. Okay, now we're going to go to our third piece. So first we want to know it's a horizontal line, so it's y equals a number. So what number is this equal to? It's equal to 43. And it's equal to 43 for between what x values? Well, this is between the x value of 2 and 3. So 2 is less than x, which is less than 3. Now, is there a closed dot? There is at 3, so that means we put an equal to symbol under the 3. All right, now if we go to the next ones, it's very much similar. So here our y value is 45, and this is between 3 and 4 has an open dot, or closed dot, so it has an equal to symbol. Next, we're going to go over, and we have 47, and this is between 4 and 5. So 4 is less than x. 5 has a closed dot, so it gets an equal symbol. And then our last one here is at 49, and that's between 5 x less than or equal to 6. Okay, so now that we have our function all written out, now we can ask a follow-up question. So here we go. If it cost Trina 47 cents to mail her letter, how many ounces did it weigh? All right, well, it cost her 47 cents. So what we want to do is we want to look carefully for 47 cents. So I can either look at the graph or I can look here. I'm going to go up here and take a look. Well, here's 45 cents. So her package had to be between 4 up to 5 ounces. So that means it had to be more than 4, not equal to 4, but more than 4, but less than 5 ounces. And I could have told that by the graph too. I could have gone up to 47 and over and saw, well, it's between 4 and 5 ounces. And that's how we figure it out. All right, so what I'd like you to do now is I'd like you to take a look at the third one just for a second, and I'd like to see if you can interpret the piecewise function here. So the function f gives the cost to ship X pounds via FedEx, standard overnight rates to Zone 2 in 2013. So this is how much it costs. Okay, so this is the cost, and then this is the weight in pounds. The weight in pounds. All right, so let's go ahead now. We have to interpret this. So how much would it cost to ship a 3-pound package? So for 3 pounds, that's your X, so that's the weight. So let's look for 3. Well, there's a 3 here and there's a 3 here. Well, which one do we want to use? We want to use the one where there's the line underneath because that means it's equal to 3. So that means we're going to use this first one because it's equal to 3. So that means how much is it going to cost? $24.70. All right, now let's take a look at the next one. How much would it cost to ship a 7.25 pound package? So we want to go, it's going to be more than 7, but it's less than 8. So where would that go? More than 7, less than 8. So that one would be right here. So it would be $31. So now the next time you walk into a FedEx store, now you know how to read the sign to know how much it would cost to ship your package overnight. All right, ladies and gentlemen, this is a nice little brief introduction to our step functions, which are just fancy piecewise functions. So what I'm going to have you do now is flip over to your video 10 worksheet, and there's 1, 2, and 3 questions here. So number 1, you're going to graph. Number 2, this is where you're going to have to write out your function. So f of x equals, and there's 1, 2, and there's 3 of them. So you have to write out those 3 pieces. And number 3 is a multiple choice question. Have a great night, everybody, and I will see you all tomorrow.